Hello everyone, welcome to the third class of Science with Jane. It is Wednesday, March 18th. We are back outside because here where I live, it's super nice out and sunny, a little bit cold. So we're going to do an episode outside. And the beginning of this episode, we're actually going to combine one thing about the first episode, which was about trees, and one thing about the second episode, which was about Sir Isaac Newton and physics. And so I'm just going to set the scene. So if you remember from last time, we learned that Isaac Newton, this was before he became Sir Isaac Newton. Anyway, he was sent home in 1665 because his college in England closed completely because of a disease called plague. So he had to go home and stay there for a long time. His mother's back home had a garden that he could go into. So he was allowed to go outside, kind of like I can go in my backyard right now and hang out. So that's pretty nice. So there's this story about Isaac, that he was sitting under an apple tree in his backyard, and an apple, I have an apple, see, trees, apples, fell from the tree and hit him on the head. And this made him think about why the apple had fallen. And then, because he was Isaac Newton and he thought a lot about how math explains the world, it led him to developing the law of gravitation, which explains the math of how gravity works. And we still use the same math that he developed then in like 1665-ish to explain how gravity works. So most historians don't think he was actually hit on the head by an apple. This is probably just a good story that describes his situation. He needed to stay home to stay healthy. And it described his family's garden. There really were apple trees there that the family used for food. And it also describes his work during that time. He figured out the math of gravity. So it's kind of a fun story to have like a tree situation and a gravity situation and a Sir Isaac Newton situation all together. So the theme of our episode today is gravity. So Newton did a really good job of explaining the math for gravity, but he couldn't actually explain why gravity pulls things down, or towards each other actually is the more proper way to say it. Or he couldn't really explain like why gravity exists and what it actually is. In fact, scientists are still working on that. So there was another scientist, which you may have heard of, named Albert Einstein, and he predicted the existence of gravitational waves way back, a little over 100 years ago, in 1916. And he said that he thought that was what was causing actual gravity. So 100 years went by, since he predicted gravitational waves. So now we're 100 years from then, would be 2016. So 4 years ago from today, scientists detected those gravitational waves that Einstein had predicted using something called LIGO. Now LIGO it's not Lego, stands for Laser Interferometer Gravitational Wave Observatory. And this is a really cool system of like underground tube like tunnels that can shoot lasers and detect gravitational waves hitting Earth, which is like really, really cool. I am not an expert in gravitational waves. However, if you're interested in it, I put a video so I put a bunch of links today because gravity is such a far-reaching topic. So if you look at the bottom of this video on YouTube, there's a link to a document. And the first page of that document lists a bunch of different things that you can watch or listen to. Number one, there's really good information about gravity and tons of other topics on BrainPop. BrainPop, you need a login. Some of you might have the login from your school already. And there is a message on BrainPop saying that if your school is closed, you can get free access. So you might want to check that out with a parent if you're interested. I put the link to the BrainPop Junior, which is like kindergarten through third graders, about gravity, but the regular BrainPop without the Junior uses the same login, also has videos about gravity and Newton and forces. The next thing I put is a link to the Brains On podcast about gravity, in which an astronaut describes what it's like to hang out in microgravity in space. Then I also have another Brains On called What's Behind the Waves and Tides. This is like ocean waves, not gravitational waves. But the beginning of this episode, there's an actor pretending to be Sir Isaac Newton, because he has already died, describing the math that explains gravity, because tides and gravity, super connected. And then The final thing on this very long list is the link to the little video. It's about 5 minutes long that explains the LIGO experiment, and it shows what gravitational waves are, or at least what scientists think they are, because this is something we're still learning. Okay, so our activities today are not going to deal with gravitational waves. That's a little complicated. Instead, we're going to kind of go back to looking at experiments that people just figuring out not why gravity exists, but just how it actually works on Earth, experiments that they would do. Okay, so there's 2 activities, and there's for younger kids, this one, and then for older kids. For the older kids, the first page of yours is actually the exact same as the younger kids, because you kind of need to start there and then move on to the math stuff. So here's what we're going to do. So we have 2 forces when you drop things. Okay, so when this apple was falling and hitting, in the story, probably didn't really happen, Sir Isaac on the head, gravity was pulling it down, and then the air in the atmosphere was actually pushing back up on the apple. But in the case of the apple, the force due to gravity was much greater than the force due to the air pushing up. And so the apple fell pretty quickly. I've never been hit on the head with an apple, been hit on the head with other things like a ball or something, and it hurts a lot because the air doesn't do that much to slow the ball down, and the ball or the apple falls pretty quickly. Okay, so here's your experiment. You are going to get 2 pieces of paper that are the same size. It can be any size, they just have to be the same size. You're going to make one into a ball and keep the other one flat. Here, I'll demonstrate. So you make one page a ball and then keep the other one flat. All right, now you're going to drop both papers at the same time from the same height. You can stand on a chair or some steps so that they have a longer distance to fall. So it's easier to see the difference if you drop them from higher up, but you need to be safe. Like I could drop them off the side of the treehouse, which is pretty high up, but only if I had permission from a parent. I actually am a parent, so I can give myself permission. So you can go on like some steps or a chair, or you could have a tall adult or brother or sister drop them for you, okay? So you're gonna drop them at the same time, and you're going to decide which one lands first. How do they fall? Record your data. So I have space for you to do 5 tests. Ball of paper, flat paper, put an X under the paper that lands first for each test. So sometimes it might be easier to have one person observing which one lands first and another person dropping, okay? So you would just put an X under whichever one landed first for each test. This last row is for the total. So you would count up your X's in this column and write the number there, and count up your X's in this column and write the number there. Now you have data that you can compare. Down here, there's a space for you to draw the way that these 2 types of paper fell, the ball of paper versus the flat paper. You can use arrows to show motion, okay? So a lot of times scientists use diagrams to show something, and sometimes an arrow can represent a force, but it can also be used to show which direction something moves. And then talk about it. Here are some questions to talk about, or just to think about. Which paper usually landed first? So you want to look at your totals here to figure that out. Which paper usually landed last? Which paper could air push on more? How did air pushing up change how fast the paper fell? So that's something you want to think about. And also think about, are there other objects that you want to test with this same dropping thing? Okay, and if you need more space, you can always record data on the back or print this again and change your headings to your new objects. You can do it basically any way. All right, so that's it for younger kids. Older kids, we're gonna get to the next page, which involves some math about gravity. All right, moving on. Here I go, turning the page. Okay, so we can also measure average speed, which we did last video in the speed video, with things moving like along a straight line on the ground. But we can also measure speed of objects that are falling through the air. And we would do average speed, which is the total distance divided by the total time. And that can give us information about the forces acting on objects. So essentially, I think you should do the For Younger Kids page first, just to practice your dropping skills. And then you're going to want to figure out how you're going to measure distance and time. So for distance, again, distance is tricky. You can watch the other video about distance to look at different ways you can measure distance. You're going to pick a specific height to drop the papers from. We're just going to still use papers. Measure the distance from your drop point to the ground. So this could be tricky if you're up really high. So if I were to do this from the treehouse, I could use a measuring tape to go all the way to the ground, maybe. But let's say I only have a ruler, or I want to use like the my own foot method of measuring. In that case, what I think you should try is getting a piece of string or rope or ribbon, whatever you have, and then you can hold that straight up in the air. And then mark with, like, you could actually cut it where you're going to drop it from once it hits the ground, or you can mark it with a Sharpie and then lay it flat, and you can measure it out just like you would measure a track or like the distance from one side of the room to the other. Okay, so that's my suggestion for figuring out how to measure distance. There's lots of ways to solve that problem. Maybe you'll have a different way. Okay, so you have the distance, and the distance, again, in our lovely chart here, you're going to keep the same height, at least for this initial test. You could change that later. So you would write the distance all the way down the same, and you would use your units as whatever you use. So it could be feet, it could be inches, it could be meters, it could be Jane feet, or like your own foot, however you want to do it. Now, you're going to measure time. So you probably need a stopwatch that's going to give like fractions of a second, which will mean on the stopwatch, it'll show seconds and then the decimals of the second afterwards. So I really suggest, because this is going to happen pretty quickly, that your unit here is seconds. And you might need to use decimals when you record it, okay? If you're not comfortable with decimals, you can just use the whole number seconds. Okay, so then you would do this where you're dropping the objects. I've left a space for object name here. You already have your distance. You're recording your time. You might need someone to drop and someone to time. Maybe you could do it all on your own, but it might be tricky. And then to get the average speed, you would take your distance number and divide by your time number, and that's your average speed. So to get more accurate data, you can measure the time of each type of paper 3 or more times, average these times together, and then use this average to calculate speed. So this is a much more challenging data collection because it's happening very quickly, and you have to time like the dropping with the starting the timer with the stopping the timer when it hits the ground. And you only want to do one type of paper at once, so you can collect that data. In the first page, you're just comparing, okay? So this is a challenge. I think you can do it, but one way to get accurate data is to do it several times and then average those numbers, okay? So there's space for you to do that here if you know how to average. If you don't know how to average, that's fine, just do it once. And then I've also left space to test other objects and compare their speed. So you can test other things too. I've included a lot of rows on the data table so you can collect a lot of data. You can always use the back too, print it again, collect more data. So here are some questions for you. Which objects fill the fastest? Which fill the slowest? Was it hard to collect this data? Why or why not? Can you think of objects that humans build that use the force of air pushing? So we actually take advantage of this idea that air is going to be there providing a pushing force against the direction of an object moving. So you can kind of think about that. Sometimes we actually even take advantage of wind to make things move. There's a lot more we could do with that. Maybe that'll be another class. Okay, so basically gravity is awesome. It works. It keeps things where they are here on Earth. And I think one important thing about gravity, now that we're in the big place, and this is something that Newton described, is that all objects have gravity. So this apple has gravity. It is pulling things towards it, but the apple is really, really small in terms of its mass compared to the Earth. So on Earth, the Earth is the thing whose gravity wins out over all other gravity because it's so big and so massive that it pulls things to it. There's kind of an exception to this, and it has to do with tides. I'm not going to tell you the answer, but if you want to listen to the brain pop, sorry, not the brain pop, the Brains On that I linked that's about the tides and waves, it explains how gravity is connected to tides and how Earth's gravity is not the only thing that really makes an impact on our planet. So I'm gonna leave you with that. I hope everyone has a great day. Stay safe and wash your hands. Okay, bye.